We have been given a quadratic sequence, so 3x and 11. And they told you the formula for the general term is Tn equals 2n squared plus bn plus c. And they want you to determine what x is. Now, we're going to draw our little steps quickly. First term, first difference, second difference, and that's going to be a plus b plus c, 3a plus b, and 2a. And remember, as soon as they tell us that it is a quadratic sequence, that means that the second differences are equal. Okay. So think about what your pattern is. Find your first differences. Find your second differences. Then do an equation and tell me what the value of x is. And if you hit a roadblock, let me know. I'll tell you. Oh my goodness, that's a third yawn. I'm so sorry, guys. I don't know what's wrong with me. I cannot stop yawning today. If you hit a roadblock, let me know. I will highlight something which I think will be helpful to you. I'm actually going to do it in a different color. I think that will be helpful to you. That's what I think. Oh, Abu, don't act like you didn't love linear sequences on Tuesday. We all saw it happen. We all saw you fall in love with linear sequences. There's no denying it. Hi. Uyanda, where were you on Tuesday? You were not here. Were you here on Tuesday? I feel like you weren't here on Tuesday. Am I losing my mind? Were you here on Tuesday? You had me questioning my sanity. Interesting, Abu. Very interesting. I don't agree with it. But I don't hate, there's a lot in there that I don't hate. It's a lot of things that I like, actually, but I don't like the final answer. I'm going to give you guys 2 more minutes to give this a try. 2 Earth human minutes, and then we will go through it together. I did warn you. Ooh, how did I stop sharing my screen? So, I did warn you that we have some spicy questions this evening. I'm not sure how I did that, guys. I'm sorry. Okay, 1 more minute. Oh, Boo, you're going to be so grumpy when you see what you've done. Okay. Before I do anything with my first differences and second differences, I want us to have a look at this dude over here. Now, remember that this formula is an squared plus bn plus c. Okay. They've told us that this first term is 2n squared. That means that a is 2. They have told us that piece of information. So we know that our second difference needs to be 4. So 2 times 2. Okay, that's the first piece of information. Second piece of information, let's look at our differences. This is term 1, term 2, term 3. First difference is going to be x minus 3 and 11 minus x. Second difference is going to be 11 minus x minus 3. And that has to be in brackets because we are subtracting this whole term. So we have 11 minus x plus 3, which leaves us with 14 minus 2x. So Boo, what you'll see in yours is you have got 2x minus 14. It is just the wrong way around. We now know that this is our second difference, and we know that our second difference is 2a. Second difference is 2a. We know that a is 2 because of this. And we know that our second difference is 14 minus 2x because of this. So 14 minus 2x equals 4, which means negative 2x equals negative 10. And so x is equal to 5. I thought you would be grumpy, yes. If you didn't get it, don't panic. Every question we do tonight is quite spicy. Tebogo, sure. Can you tell me where you got lost? And that's where I will re-explain from. The second difference. Okay. I'm just going to erase this for a second. And give myself a little bit more room. Okay. Okay. So my first difference is going to be term 2 minus term 1, so x minus 3, and this one is going to be 11 minus x, right? So that's term 3 minus term 2. This is now a term, and this is a term. So to find my second difference, I have to take my 11 minus x minus my x minus 3. So I need to substitute that negative sign in. So I'm going to have 11 minus x plus 3, which is going to give me 14 minus 2x. So I now know that that is my second difference. Okay. I also know, because they told us that a is 2, because of this, I know that when I'm thinking about this, my second difference has to equal 2a. But we know that a is 2. And we know that our second difference is now 14 minus 2x. So that's what we're doing over here. Our second difference is equal to 2a. This is our second difference. That's what we worked out over here. And the 2a is because we know a is equal to 2. So 14 minus 2x is going to equal 4. So negative 2x is negative 10, and x is equal to 5. Anytime! That's why I'm here. You must always ask questions. Take a screenshot if you would like, and then we will move on to our next spicy question. What am I doing, guys? All over the show tonight. Okay. Cool. Okay. If it is given that b is equal to negative 4 and c is equal to 5, determine whether 970 is a term in the sequence. So your general term would look like this. We know a is 2, b is 4, and c is 5. And we want to know whether 970 is a term in the sequence. My hint to you in this question is that the quadratic formula will be your friend. And if you need help with that, Okay, so if you get a decimal, then can it be a term? No, exactly. So when you have a question like this, if it's asking if it's a term in the sequence, basically what it's asking you is if n is a whole number. If n is a whole number, then it's a term in the sequence. If n is not a whole number, it is not a term. So n whole number, term. N not whole number, not a term. Okay. So what we're going to do is we're going to pop it into our quadratic formula over here. So what we've got is 970 is equal to 2n squared minus 4n plus 5. Whenever we use our quadratic formula, it needs to equal 0 on the side. So we're going to move that over. So we're going to have 2n squared minus 4n minus 965. So that means that A is 2, B is negative 4, and C is negative 965 for this. Okay, so that means N is equal to negative 4 plus or minus root negative 4 squared minus 4 times 2 times negative 965 all over 2 times 2. And when we pop that into our calculator, we'll get 2 answers, always 2 answers, because there's a plus minus. So n is going to equal 22,99, or n is going to equal negative 20,99. Both of these are decimals, which means n can't equal either of them. So therefore, no, 970 is not a term in the sequence. If that doesn't make sense, please let me know. If it does make sense, that's great. If it doesn't, let me know. Okay. Take a screenshot if you would like. The next one continues on our journey of spice. Okay. A quadratic sequence has term 3 equaling 9. The first differences form another sequence. The general term Tn equals 6n minus 4. So we know this is term 1, term 2, term 3, term 4, term 5. We know that term 3 is 9. And we know that our first differences are going to have a pattern of Tn equals 6n minus 4. Okay. So the question here is to determine the first two terms of the quadratic sequence. I'm going to give you some time to think it through. Can you assume? No, you can never assume anything. Haven't you heard that saying? If you assume, you're making an ass out of you and me. T2 is not 3. What's the deal with boot camps? My mom wants to know what happens there. It's okay, so it starts towards the end of October. I think the dates are, I have now forgotten them, but I think in last weekend of October, and then the 2 in November. We're going to do some study tips, so how to sort of like ace studying for maths, and like how to make sure that you maximize your time when you're doing maths work. And then we're going to focus on exam questions for paper 1 and for paper 2, and I'll give you a bunch of resources to try and help do some extra practice in your own time. So every paper I give you, I'll make sure to give you the memo. Yanda, it's a good question, and I should know offhand, but I don't. Let me look for you, though. For you, I will look. Let's see if I have it in here. Okay, grade 11 boot camp. Session 1 is the 25th of October. Should I put this in the chat? Okay. Session 1 is the 25th of October. Session 2 is, did it go in the chat? I swear I typed it. Where did it go? So weird. Oh, no, it's there. Okay. 1st of November, and then the third session is 8th of November. Those are the 3 sessions. And it is 449 Rand for all 3. And it's going to be on Saturdays from 2:30 to 4. There you go. Okay, let's talk about this question because it's quite a spicy question. Remember, there's some important things here. The first differences of a quadratic sequence is always a linear sequence. And then our second difference is the one that's equal to each other. Okay, so if this is the formula for our first differences, then if n is equal to 1, it would be 6 times 1 minus 4. So 6 minus 4, which would be 2. If n was equal to 2, it would be 6 times 2 minus 4. So 12 minus 4, which would give me 8. And so I am increasing by 6 each time. So that means that this term here, so because these are my first differences, this term would be 2, this term would be 8, this term would be 14, this term would be 20. So now, if I know what the first differences are, if I know that the difference between term 3 and term 2 is 8, then this must be a 1, because 9 minus 1 will give me 8. Yes, and if this is a 2, then this needs to be minus 1. So the linear sequence is telling you the different terms of your first differences. And we can always just work that out by making n1, n2, n3, whatever we need. And then our second difference is always going to be that constant difference. So in this case, it's going to be 6. So the first two terms of the quadratic sequence, term 1 is -1, term 2 is 1. Quite a cool question, though. Okay. Let's try and expand those brains a little bit more. Okay. Calculate the value of term 43 minus term 44 minus term 33 of the quadratic sequence without determining the value of these terms. So I'm just going to write the things that we know so far. We know that this is what our sequence looks like. Okay. We know that our first differences look like that, and that they are following the formula of Tn equals 6n minus 4. And then we know that our second difference is going to be 6. Okay. But the key here is to do it without determining the value of these terms. I'm going to write some things up here which I think might help. Some little hints. If it helps, simplify it for you. Interesting. I like a lot of what you're saying, but not all of it. I'm going to give you guys 2 more minutes on this. But I like a lot of what you're saying. Wrong path, Uyanda, because you don't need to be working in the quadratic line. You need to be working in the linear line, because what you're looking at is a difference between 2 terms. Okay, let me take you out of misery. Term 1 of our linear sequence of our first differences. So term 1 is equal to our quadratic term 2 minus term 1. Okay. Term 2 is equal to our quadratic term 3 minus term 2. If we use this logic, that means that, so if we have a look here, that's 2 and that's 2, and we're going to try and copy this idea over here. Term 43 would be equal to my quadratic term 44 minus term 43. So that means that if we can figure out what term 43 in our linear sequence is, then we can figure out what the difference is between these two terms. We know that the linear sequence is 6n minus 4. So it's going to be term 43, 6 times 43 minus 4. So term 43, just did this and I've just forgotten, 254. And that is what the value of T44 minus T43 is. Screenshot if you would like. That's all you had to do. That's why I said you were close. You were very close. I know you had it. You were just trying to minus something else. Did you get the same answer? Yes. Okay. But wait, hold on. Uyanda. If you got the same answer using your path, the problem with your path is that you would be determining the value of the terms. You would be determining what T44 is and what T43 is. And the question said specifically without determining the value of those terms. So even though you got the same answer, they're going to give you nothing. Because remember, maths teachers are mean. The question was mean, in fairness. Okay. Yanda, you're going to be ahead of the crowd for this next question. Determine a formula for the general term of this quadratic sequence. So I'm just going to write what information you have so far. You've got -1, 1, 9, 2, and 8, and then 6. And remember your steps. And see if you can figure out the general term of this quadratic sequence. I'm just going to give everyone a couple more minutes to catch up. because you've done it in the last question. But I like your answer. Alrighty, we care about these three terms: -1, 2, and 6. And we work from the bottom up. So 2a is equal to 6, therefore a is equal to 3. Cool. 3a plus b is equal to 2. We know that a is equal to 3. So 3 times 3 plus b equals 2. 9 plus b is equal to 2. Therefore, b is equal to -7. Cool. A plus b plus c equals -1. A is 3. B is -7. C we don't know. So -4 plus c equals -1, which means c is equal to 3. Therefore, Tn is equal to 3n squared minus 7n plus 3. Oh, you know what you did, Abu? You made your a 2 instead of 3. In your very last equation, when you were doing a plus b plus c equals -1. Okay, screenshot if you'd like. I got a nice question to follow. So now you're hating on the quadratics. Maybe this is like the universe telling you you're only allowed to like one sequence at a time, and you were just giving linear too much love on Tuesday. Yeah. Okay. We've got a quadratic sequence, 5, -13, x, -67. They've told us it is a quadratic sequence. If it is a quadratic sequence, we know that our second differences are equal. So think about what that means. I shall give you some time. Did you get to the same point as this? So do you have your negative 18, x plus 13, and negative 67 minus x for your first differences? If you didn't get those, that might be where things went wrong. Okay. So then we're just doing our next level from here. So we're saying x plus 13 minus negative 18. So that's going to be x plus 31. And this one is going to be negative 67 minus x plus 13. So we need to take that negative sign in. We'll end up with these two. And then remember, your second differences are equal. Here we go. So we know those second differences are the same. So we know that x plus 31 is the same as negative 80 minus 2x. So that means that 3x is equal to negative 111. Therefore, x is equal to negative 37. Did you guys know the trick about numbers and being divisible by 3? You can always tell if a number is divisible by 3. So for example, I can tell that 111 is divisible by 3 because 1 plus 1 plus 1 is 3, and 3 is divisible by 3. Any number that is divisible by 3 adds up to a number that is divisible. So you can try it with anything, but like 27, 2 plus 7 is 9. 9 is divisible by 3. 141. 1 plus 4 plus 1 is 6. 6 is divisible by 3. That means 141 is divisible by 3. Just a fun little trick. If you were ever interested, now you know. And even if you weren't interested, now you know. Thanks, Boho. I'll take it. Okay, next question. Hence or otherwise determine the nth term of the sequence. I suspect they get put on, the link gets put on Google Classroom, Leander. I think that's what happens. Hence or otherwise determine the nth term of the sequence. So we now know that x, this x over here, we know that that's negative 37. Doesn't really affect us, to be honest, but hence or otherwise determine the nth term of the sequence. I think let's make this our last mission of the night. So let's see if as many of you as possible can get the right answer. I'll give you some time to make sure you're happy with what you've done. Don't forget your steps. Don't forget to work from the bottom up. Yes, the hence in here is your clue that it can be done slightly quicker. Exactly. Yeah. Both great thinking. Okay, 2 more minutes. Okay, so the clue here was the hence to make our life easier. You didn't have to, which is why it said or otherwise, but the hence is what's going to make our life a little bit easier. So I'm just going to try and make this so that we can see our steps still. So these are our steps, right? A plus B plus C, 3A plus B, and then 2A. And we can actually just use what we already have. So we've got the 5, then we've got negative 18, and here we've got x plus 31. And we know that x is negative 37, right? So let me scroll down here now. Okay, So we always work from the bottom up. So x plus 31 is equal to 2a, but we know that x is negative 37. So negative 37 plus 31 equals 2a. 2a equals negative 6. Therefore, a is equal to negative 3. 1. Step 2, negative 18 is equal to 3a plus b. That's a really weird b, but you know what I'm talking about. Negative 18 is equal to 3 times negative 3 plus b. Negative 18 equals negative 9 plus b. Negative 9 is equal to b. Done. Last step. A plus b plus c is equal to 5. A is negative 3. B is negative 9. C we don't know. So we have negative 12 plus c equals 5. So c is equal to 17. So therefore, Tn is equal to negative 3n squared minus 9n plus 17. Pretty cool, right?